Hello and welcome to this installment of the NIE Sustainability Learning Lab video series on water quality. In today's clip, we will examine the importance of dissolved oxygen as an indicator of ecosystem health, and we'll also measure dissolved oxygen with the help of Ms. Grace Wee from NIE. The first question that we might ask is, why is dissolved oxygen so important? Of course, just as we need oxygen to breathe, aquatic organisms also need oxygen. However, while we breathe in to get our oxygen from the air, aquatic organisms get their oxygen by taking the oxygen that's dissolved in the water out of the water. So for example, as we see in this video clip, the water is taken in by the fish through its mouth. The water then passes through the gills, and through this process, the oxygen that's dissolved in the water is taken out through the gill system, and then the water carries on and leaves the fish's body. So as we can see, dissolved oxygen is a very important indicator of ecosystem health.
So Prof, how much dissolved oxygen does the water actually need?
That's a good question, Grace, and it depends on the organism. Some organisms require higher dissolved levels. Other organisms can survive on lower levels of dissolved oxygen. In general, however, an average of around 4 to 5 milligrams per liter is sufficient to ensure a good level of ecosystem health. The next question we might ask is, where does the dissolved oxygen come from? The main source of dissolved oxygen in the water actually comes from the air. Now, the oxygen coming from the air starts to mix with the water, and of course flowing water then and turbulence, that is part of the flowing water, helps to mix the oxygen into the water.
So Prof, does this mean that a faster flowing stream will have higher levels of dissolved oxygen than a still pond?
Yes, Grace, in fact that's a good observation. Generally speaking, the faster the flowing the water, because that has greater turbulence, allows the oxygen to mix, whereas a slower moving pond or a still water, such as we have here, would generally have lower dissolved oxygen levels. Here we are at Bishan Park, and we're going to observe the Klang River. The Klang River used to be a concrete channel, just as many other drainage channels are in Singapore. However, the PUB has done a wonderful job of naturalizing the river, and that's what we're going to look at now. So, here we are in Bishan Park.
Yes, Prof. As you can see, the design included the construction of pool and riffle sequences that are found naturally in rivers and streams. The increased turbulence and velocity helps to mix oxygen from the atmosphere into the water. This will help to enhance biodiversity.
This graph shows dissolved oxygen data for this site that was measured every 15 minutes. The y-axis is dissolved oxygen in milligrams per liter, and the x-axis are the measurement time steps every 15 minutes. As we see from the red circles, DO is highest near the solar noon due to photosynthesis. At night, photosynthesis stops, but the green plants and algae continue to respire, which requires oxygen. Therefore, as shown by the green circles, the dissolved oxygen levels are low at night. In addition to photosynthesis and respiration, there are a number of other factors that can influence the level of dissolved oxygen in a water body. Two important factors include water temperature and the presence of organic pollution. In the case of water temperature, warmer water has less capacity to hold dissolved oxygen than colder water. As a result then, the concentrations of dissolved oxygen in warmer water are lower than concentrations of dissolved oxygen in colder water. And this is very well illustrated by this animation. The second factor that we might discuss that influences the dissolved oxygen levels in a water body are the presence of organic pollution. If we have high organic content in a water body, for example from a sewage discharge, that organic material will start to decay. That decay process involves oxidation, and essentially that is reducing or using up the oxygen in the water, and as a result then the dissolved oxygen levels decrease. Therefore, dissolved oxygen is a very good indicator of the potential for pollution from organic material, and in particular, the potential for waste discharges.
Let us now show you how to measure dissolved oxygen. First, we will take a water sample from the Jurong Eco Garden using a baler. Before you collect the sample, ensure that the dipper has been rinsed 3 times. There are a range of methods to measure dissolved oxygen. Today we will be looking at 2 different colorimetrics kits, one provided by the PUB and another obtained from Chem-Metrics. We will now measure dissolved oxygen using the PUB kit. First, fill the small vial provided in the kit with water. Make sure that the vial is fully filled and that there are no bubbles. Then, drop 2 dissolved oxygen tablets into the vial. After you cap the vial, dissolve the tablets by shaking it from side to side. Once the tablets are fully dissolved, allow for 5 minutes for the colour to fully develop. Compare the colour of the sample to the dissolved oxygen colour chart provided in the kit. You will see that there are gradations of 0, 4 and 8 parts per million. If the colour of the sample falls in between these categories, it is okay to estimate the concentration. In this case, we can say that the level of dissolved oxygen would be about 2 parts per million. We will now measure dissolved oxygen using the Chem-Metrics kit. First, fill the sample cup up to the 25 milliliter mark. We then insert the ampule tip first into the sample cup. Gently snap the tip by applying some pressure. Leave the ampule in the sample cup until it has fully filled with water. You will see that a bubble has developed. This will help with the mixing of the sample. Gently invert the ampule to allow the bubble to travel from end to end. We will now wait for 2 minutes for the colour to develop. Compare the colour in the ampule to the colour standard provided in the kit to determine the concentration of dissolved oxygen in parts per million. In this case, we can see that the level of dissolved oxygen is about 5 parts per million.